Alright, continuing where we left off for chapter 4, section 1. We were looking at the charges on the metal ions as well as on the non-metal ions. So the charge on the metal ion is the same as the group number, right? And the metal ion, cation, retains the same name as the corresponding element of metal. Whereas the non-metal or the anions, their charge is group number minus 8, all right, and the name for them ends in the suffix "ide." Also, the electron configuration of the metal ions resembles the noble gas that precedes it. So lithium plus lithium ion has an electron configuration of 1s2, just like helium. And sodium, magnesium, and aluminum ions have 10 electrons that resembles the electron configuration of neon. Okay. Now, the non-metal ions, their electron configuration is like the noble gas that comes after it, that succeeds it, all right, because they gain electrons, and that is determined as group number minus 8. So nitrogen would gain 3 electrons, hence the 3 negative charge. Oxygen, 6 minus 8, would gain 2 electrons and therefore the 2 negative charge. Then fluorine would gain 1 electron and so 1 negative charge, all right. And also their name ends in "ide." So they also, nitride, oxide, and fluoride, have 10 electrons. Again, isoelectronic with neon. Some of these ions are very important for our body functions, like the sodium and potassium ions, which are involved in the sodium-potassium pump. Sodium is outside the cell, and potassium, this is a typo, it's more inside the cell, all right? And the sodium-potassium pump helps to regulate body fluid, cell function, also the transport of important biomolecules like proteins and other biomolecules. Now, sodium, the main source is of course table salt, and then potassium is there's a high amount of potassium in bananas and other foods. Calcium is found in the bones, and it's important for muscle function, especially muscle contraction. Major cation in bones, and the loss of calcium and loss of bone density leads to a disease called as osteoporosis. So the source for calcium is of course milk products, and then you have magnesium, which is outside the cell, found in bones. This is essential for enzymes. It's called as a cofactor, and it also helps in muscle and nerve control. So in this study check, it says write the formula and symbol of an ion with 16 protons and 18 electrons. So 16 protons, that would be sulfur. So it has 2 more electrons, because 16 protons would need 16 electrons to make it neutral. So this would be S2 minus, which would be sulfide. So consider the elements calcium and chlorine. Identify each as metal or non-metal. So calcium is metal, chlorine is non-metal. State the number of valence electrons for each. Calcium is in group 2, so it has 2 valence electrons. Chlorine is in group 7, so it has 7 valence electrons. State the number of electrons that must be lost or gained for each to acquire an octet, and then write the symbol, include its ionic charge and name of each resulting ion. So calcium would lose its 2 electrons and become Ca2+. And that's how it would acquire an octet, 18 electrons. And chlorine would gain an electron. It's in group 7, so it would gain an electron to form an octet. And since there are 2 electrons involved, there should be 2 chlorines, all right? Each receiving an electron from calcium, and then the resulting ions are calcium ion and the 2 chloride ions. So how do you write the formulas for ionic compounds? Ionic compounds have the cations and the anions, and this is a force of attraction, all right? It's just simply opposite charges attracting, and that's a very strong attraction that holds them together. Sodium and chlorine form regular crystal kind of structures in table salt. It's 6 sodium ions to 6 chloride ions, and they're in a regular pattern like a hexagon, and they're very tightly packed. They're formed from the sodium metal and the chlorine gas, okay, 2 toxic substances, and then it forms sodium chloride, which is a very benign compound and is essential in cooking to add flavor. So, what are some of the properties of ionic compounds? What holds an ionic bond is the attraction between positive and negative ions. Ionic compounds, this attraction is very strong, and therefore to melt an ionic compound, to break that bond, requires high temperatures. So they have high melting points. Sodium chloride, to even melt a tiny little grain of sand, would require a temperature of 801 degrees centigrade. Most of them are solids, ionic compounds, at room temperature, and they have a regular crystalline type of structure in most of them. So sodium chloride or table salt is formed from sodium metal and then the chlorine gas. This is very reactive. This gas is very toxic and reactive, and they come together and they form sodium chloride, Na plus Cl minus. And it's a regular crystalline type of structure, and it's very benign. So this is toxic and reactive, and not toxic but very reactive. This is toxic and reactive, and then table salt is a very benign substance that is essential for cooking and flavoring of foods. So in forming a chemical formula between the sodium and the chlorine, the electron from sodium is transferred to the chlorine. Now sodium has a positive charge, the chloride ion has a negative charge, and you can see that the sodium atom was larger, but then the sodium ion is smaller. Again, the chlorine atom was kind of small, but the chloride ion is fairly large. In magnesium, 2 valence electrons are given, 1 to each chlorine, to form MgCl2, right? So Mg gets a 2 positive charge. Each time you lose an electron, what's the remainder? The atom gets a positive charge, all right? So 2 electrons are gone, so there's 2 positive charges on Mg, and each chloride has a negative charge, which balances out the 2 positives, and so the net charge is 0 for MgCl2, which is named as magnesium chloride. So the key thing when writing formulas of ionic compounds is that the total positives should balance the total negatives, all right? So you have 2 Na plus, and you need an S2 minus, and so 2 positives and the 2 negatives they balance out, and so the net charge, all compounds are neutral. There is no charge in compounds, they are neutral. So write the ionic formula of the compound Ba2 plus and Cl minus, and it'll be similar to MgCl2 because you need two of these Cl minus to balance out the 2 plus on barium. So it would be BaCl2 barium chloride. Another quick way of writing ionic formulas is to use this crisscross, and I just gave it a catchy label, crisscross applesauce method. So if you're making the formula, writing the formula of magnesium phosphide, the magnesium ion is a 2 plus, phosphide is a 3 minus, all right? So the opposite numeric value of the charges go to the opposite atom. So the 3 of the phosphide goes to the magnesium, and the 2 of the magnesium goes to the phosphide or phosphorus. So the new formula is Mg3P2. So that's the ionic formula of magnesium phosphide. So it says here, select the correct formula for each of the following ionic compounds, all right? So it would be Na2O, B, and then AlCl3, which is A, and then Mg3N2. So Mg3N2. So how do you name and write ionic compounds? You start out by writing the name of the metal. This is Ki, is potassium, and this is called as a binary compound because there are just two elements, the metal and the non-metal, and so this is named as potassium iodide. So you start by naming the metal first, and the same name as the element, and then the non-metal and the suffix "ide" for the non-metal. All right, and there's a little space between the name of the metal and the non-metal. So potassium iodide, it has the metal ion K plus and the non-metal ion I minus. Magnesium bromide, and magnesium is 2 plus, but the bromide is 1 negative. Okay, so you have two of them to give you the cancellation of the charges. Aluminum oxide would be Al2O3. So what are the steps for naming compounds? Identify what the cations and anions are. First start with the cation and then name that anion. If it is just one single anion, then you are ending that name by the suffix "ide." And then you write out the whole name for the compound, starting with the cation and then ending with the anion. Okay, so name K2O. K is potassium, O is oxide. This is a binary compound, so potassium oxide. Write the names of the following compounds: calcium oxide, aluminum oxide, and magnesium chloride. Write the formulas and names of the compounds for the following ions. So NaBr, sodium bromide, Na2S, sodium sulfide, Na3N, sodium nitride, AlBr3, aluminum bromide, Al2S3, aluminum sulfide, and ALN, aluminum nitride. It'll stop here.